Welcome to this Maths Made Easy video on differentiation. And to start with, we're just going to take a look at the notation we use when differentiating and the formula. So to start with, let's just take a general curve here. Let's say we have the equation of y equals x to the n. We could also write this using function notation, which would be fx is equal to x to the n. Now here, if we want to find the derivative, the way we write this for y equals x to the n would be dy by dx in that case. And we read this as the derivative of y with respect to x. And if we're using function notation here, then in that case, again, we read this as f prime of x. So that's how we denote that we have differentiated f of x there one time. Now what would the formula be here? So let's use a different colour just to highlight what's happening here. Well, in this case, we obtain n. So what happens is if we have x to the n comes down to the front and we times it by x, so that becomes nx, and the power becomes n minus 1. So just to make it clear what's happening, and if we put this back in black then here, this becomes nx to the n minus 1. Okay, so the power comes down to the front and we times it by x, and then we reduce the power by 1. Okay, and it's clearly the same here. Again, the colours would be the same, but we just write out in full. This is nx to the n minus 1 there. Okay, and this derivative gives us the formula for the graph's gradient for all x values. Okay, so let's take an example here. Let's say we have a really basic quadratic of y equals x squared. If we want to find the derivative here, dy by dx, then again we apply this formula here. So in this case, the 2 is going to come down to the front, and again let's just highlight this in a different pen colour. So this becomes 2 times x, or 2x, and again we won't write the x in just yet. Let's just think about the power here. Well, the power is reduced by 1, so this becomes 2x to the 2 minus 1. And if we put our x back in here, just so we can see it clearly, it's 2x to the 2 minus 1, and this will just simplify to give us 2x there for dy by dx. We can simply extend our rule and formula here for differentiation when working with negative and fractional roots. So for example, if we have y equals 1 over x, and we wanted to find the differential of this with respect to x, that would simply give us dy by dx. Now here, to differentiate this, we need to write this in index notation. And being confident with indices is a real crucial skill for differentiation. So here, 1 over x, we can simply write that as x to the minus 1. And if we differentiate this now, all we simply do is apply our formula here. So the minus 1 comes down to the front and we times it by x. So that's going to be minus 1x, or minus x, and we reduce the power by 1. So this is minus 1, we minus another 1 off. If we simplify that, that gives us minus x to the minus 2 there. And we could also write that, again, write it in a form here as a quotient, that would be minus 1 over x squared there. Okay. So what about fractional powers? Well, for example, if we have y equals the square root of x. Well, again, let's write this in index notation as x to the power of a half. So here, if we want to find dy by dx, again, we don't need to panic. We just simply extend our formula in terms of fractional powers. And again, we just take the half here and times it by x. So that's a half of x. We take our power and subtract 1 from it. So that's a half minus 1. Well, in that case, a half minus 1 will give us minus a half. So therefore, we obtain a half x to the minus half. And again, we can write this as a quotient here as 1 over 2 root x there. Okay. And that gives us our solutions there when working with negative and fractional roots. And finally, we need to be able to differentiate a linear combination of terms. And the way to think about this is if there is multiple terms, we just simply differentiate each term separately. So let's take the quadratic here, y equals x squared plus x minus 1. Well, if we want to find dy by dx here, so dy by dx, we simply take each term one by one. So, for example, differentiate this x squared first. So if we differentiate this x squared here, that would simply give us 2 times x to the 2 minus 1. Moving along now to the x. Again, we'll simplify all these in one moment here, down here. So moving on to the x now. Well, if we differentiate x here, well, that's a power of 1. That becomes 1 times x to the 1 minus 1. So that's going to be plus 1x, or just x, to the 1 minus 1. And finally, this minus 1 here, so don't be put off by the fact that this is just a constant. This, if we write out in full, will be minus 1 times 0 times by x to the 0 minus 1. Because if we think about it, this is x to the 0 here. Okay, so that's x to the 0. So it's going to be minus 1 times that 0. 0 comes down, and then we reduce the power here for the x. Okay, well, because this is 0 times x to the minus 1, then it clearly just simplifies to 0. Okay, so 2x to the 2 minus 1, well, that just simply gives us 2x there. X to the 1 minus 1, well, that gives us x to the 0, which simply gives us 1. Anything to the power of 0 gives us 1. And for this term here, this just gives us 0. Okay, so 2x plus 1 minus a 0 will just simply give us 2x plus 1 there for dy by dx. And that concludes this Maths Made Easy video on differentiation.